So good afternoon, sir. Ashutosh, sir. Welcome to the FDP. So can you hear me? So good afternoon, sir. Ashutosh Singh, sir. Can you hear my voice? So the session will start exactly at 2 p.m.
Hello, am I audible?
Yes, sir. Yes, sir. You are audible.
Yeah, okay.
Okay. Shall we start the session, sir?
Yeah, sure. We can start now.
So good afternoon, participants. Welcome back to session 3. So today on the topic Codes and Standards for Hybrid Electric Vehicle by Mr. Ashutosh Singh, EV engineer from ISIE India. So let me brief you about ISIE India. So a little bit. ISIE India is the most popular and favorite e-mobility motorsports education and research publication organization in India among engineering institutes and green energy research organization. ISIE India became the epicenter of green energy concept development in India. We are motivating people to work on new and renewable sources of energy. So they give the platform to new startups, innovative ideas, and to passionate people who really want to contribute to society. So from the same institute, so we are welcoming Mr. Ashutosh Singh sir to this talk. He is a graduate in mechanical engineering from ABES Engineering College of Dr. APJ Abdul Kalam Technological University, Lucknow, Uttar Pradesh. He is well expertise in design and simulation of automotive components. So his very proficiency includes concept design, product design, simulation, FEA, DFMEA, testing and validation. So he is well known in terms of presentations and publications, research papers on weighted optimization and roll cage design in UGC and Springer journals. He is one of the member in professional bodies like ISIE, SCE, and SESI. So he designed and developed a patented working model on the pneumatics in association with Honda cars. He is one of the participants of SAE events like FE Cycle and Baja. So I just want to warmly welcome to this session. Now the session is over to you, sir.
Yeah. Thank you. Thank you. Thank you for the introduction. So we will be starting with the session. Now I will be presenting and starting with the topic codes and standards for electric vehicle. Okay. So is my screen visible?
Yes, sir, it is visible.
Yeah. Okay. Okay. So shall we start?
Yes, sir, we can start.
Okay. So in this session for sustainable solution in hybrid electric vehicle, we will be having an overview on codes and standards that are used for electric vehicle. So let's get start with this. So what are the objective for introduction of codes and standards in electric vehicle? So we will be having an overview of why we require codes and standards, and then we will be having an introduction to codes and how to regulate them, and then standards introduction and how the standards are regulated in the industry. And with this, we will be also having an overview how policies and how policies are used in maintaining codes and standards. And then we will be also having an overview on challenges that are going to be faced by electric vehicle in today's world. So let's get started. So what are industrial codes and standards? Industrial codes and standards are unique method to minimize the variation and maximize the quality of finished products. So as you can see, many of the companies follow some codes, some standards for specifying their products, for maintaining a graph or for maintaining a minimum value of their product. That value or that standards is defined at the codes and standard that all the companies are going to follow. And the two major factors that are responsible for maintaining such codes and standards are interchangeability and then compatibility. So industries and all the companies mainly focus on the factor that the product that they're designing or that their product that they're manufacturing are compatible and interchangeable as compared to the other products. So in this way, some organizations are set up in India which are defining codes and standards for us. And when two industries producing the parts that needs to be assembled, they have to maintain the industrial codes and standards to ensure the quality of their product. So basically, what codes and standards specify is they will ensure that the product that is to be made is having an adequate quality, quantity, and have performed number of tests on it before reaching to the potential customer. And that's how codes and standards are established. So what are codes? First of all, so codes are any set of standards that forth and enforced by a local government for the protection of public safety and health. For example, you have seen an ISO standard marks on many of the eatable products. That is a basic code, and the specification number of set written over there is the standard. So according to that code and standard, ISO marked companies have manufactured and make their product so that they could be identified easily by the public that if they are suitable for the health and safety of public or not. And the structure safety of building, that is building codes, health requirements for plumbing, ventilation, etc., sanitary or health codes, and the specification for fire escape or exit are known as fire codes. So each and every unit, each and every single component existing is having its own code and standards, and according to their codes and standards, their functioning has been performed and established. And codes are often legal requirements that are adopted by local jurisdictions that then enforce their provision. So basically, to ensure maximum safety and to ensure the standards, to ensure the quality of a product, these things have been introduced in the world. So that's how codes and standards work. Now, we will be having some overview on standards. So standards are considered by an authority or by a general consent as a basic of comparison and approval or model. Standards tell the user how do it and are usually regarded as the recommendation that do not have the force of law. So, for example, let's take an example of an event in which I have participated. So, I have participated in a ATV design event, which is SAE Baha 2018, and then I also participated in SAE Baha 2017 also. So, what are the standards of making ATV out there? So, the basic standards that they have set for all the teams is the rule book. So, rule book is that standards that we have to follow, and based on that standard we have to deliver our product. So that's how codes and standards work coincidentally with each other. Now, what are the objective of establishing these? So the protection of general welfare is one of the common objective. So as these codes and standards are established, and due to their establishment, products are having their quality to be improved. They are having some rules over there beyond which, if they could cross the line of that, they could be declared unhealthy and unfit. And two major facts that are responsible for maintaining such codes and standards are that is interchangeability and compatibility. We have already discussed this earlier. And then when two industries producing the parts that need to be assembled, they have to maintain an industrial codes and standard to ensure the quality of the product. So basically, it focus on the quality. So more the quality will improve, more will be the demand of the that product will improve, more will be the demand of product will improve in terms of customer requirements. So that's how we are going to work on codes and standards. And in terms of electric vehicle, what we are going to see, we'll have an overview how different departments of an electric vehicle are having some specific codes and standards. For example, if a car is manufactured, then what are the testing codes of there, on which basis does the design of the car is considered to be expectable, and what are the considerations that are to be taken while designing a vehicle, what are the standards that are going to be considered over there. So we'll have an overview of different departments of different codes and standards. Now, objective, the protection of gender welfare is one of the common objective. We have already considered this. So having some trade codes over it. So types of codes are professional society codes, statutory codes, safety codes, and trade codes. So different professional units are using different types of codes over for their components and equipment to be manufactured and delivered. And similarly, we are having different types of standards, having commercial standards, proprietary standards, government standards, product standards, and international standards. Some of the international organizations for standards and codes are ANSI, ISO, and ASTM. We'll have a look over them moving ahead. So these are the some organizations having which have specified some codes and standards for us. ASTM, ANSI, and ISO and national specifications. So ASTM is American Society for Technique Testing and Materials. So it develops and publishes voluntary consensus technical standards for a wide range of materials, products, system, and services. And similarly is ANSI, which is American National Standards Institute. The same functioning of ASTM is considered to be a functioning of ANSI, which is it look after the development of voluntary consensus standards for products, services, processes, system, and personnel. And then comes there is ISO standard. Then ISO is International Organization for Standardization. It ensures quality, safety, efficiency of products, services, and systems. So these are the major departments and organizations. On the basis of which codes and standards are established by them. So we will having a look over introduction to regulatory bodies for maintaining codes and standards. For in India, as compared to the foreign countries, we will be having Ministry of Shipping, Roads and Transport and Highways for maintaining codes and standards in terms of road, shipping and transport, and then Center Motor Vehicle Rules, and then Indian CMVR regulations having number of special regulations for battery operated vehicle, and then Indian government encourages the development of electric vehicle in India. So these are the basic standards organizations that are established by the government of India to develop and to encourage the use and the development of and manufacturing of electric vehicle in India. So these are the three organizations that are having a regulatory power of design and development of electric vehicle. Now, what are the automotive industry standard functions? So automotive industry basically focus on preparation of new standards for automotive items related to safety. For example, a seat belt is manufactured. Then a seat belt which is manufactured is having its own codes and standards, and according to those codes and standards, it is going to be manufactured and then put it in the vehicle. And then the other point is to review and recommend amendments to the existing standards, and then recommend adaptation for such standards to CMVR Technical Standing Committee. And this thing is done by ARAI and this ICAT. These are the organizations that give standard organizations certifications to the component or to the vehicle that are going to be manufactured. And then recommended commissions for testing facilities at appropriate stages, and then recommend the necessary funding for such facilities to the CMVR technical standing. Okay, so this is the major function that these automotive industries standards going to function over there. Now, will we have an overview of some of the codes that are currently used by industries? So they are having some codes such as AIS 038, which define the requirements for construction and functional safety. Okay, and then we are having code of AIS 039, which is having a measurement of electrical energy consumption. And then another code of AIS 040, which is having a methods of measuring the range. And then AIS 048, which specify the battery safety standards. So each and every components of a vehicle is specified a different with a different code, and each and every code has its own rules and regulations according to which a component is to be designed and developed. And after passing all the required rules and regulations established and mentioned in this code, then only a component is to be used in a vehicle. So that's how codes and standards going to function. Now, moving ahead, these codes are of traction battery, AIS 048 having battery safety standards and regulations, which is used for preventing from the heating up of neighboring cell within a module. And then for this, various tests are required, like mechanical shock test, drop test, vibration test, and many more. So while designing a battery, so we have to consider some of the major specifications that it should not be heated up to a particular temperature, or if it get heated up, then it will get blast or it will stop functioning from there, and due to that the overall efficiency of the vehicle would reduce. Okay, and to maintain the standards or to maintain the quality of the product that are going to be delivered by the companies, this battery safety standards and regulation is going to be followed by them. Now moving ahead, the codes for EV chargers. AIS 138 is the code for AC conductive charging for slow charging. And then AIS 138 part 2 is the DC conductive charging code. And then IS 17017 is the Bharat electric vehicle charging code. So these are the major codes and standards that are going to be established by the companies. And these are going to be rigorously followed by all the manufacturing companies that are going to be present and that are going to be manufacture an electric vehicle in India. So based on these codes and standards, all the components are going to be designed and developed. So after this session, we will have a look on different codes and standards that are going to be established and shown and given by the standing committees of these codes and standards. And ARI is one of such committee which specify these codes and standards for all the organizations. Now, having AC001 standards, it shows that if a AC vehicle, AC powered vehicle is made, then what are the power inputs and power output to be established over there, having some connector specification also, and EVSE and EVSE CMS communication protocols also. Basically, EVSE is electric vehicle supply equipment, and CMS is central management system. So AC001 standard specify the power input, power output, and the other specifications to be used in an electric vehicle. And as compared to AC, DC are having the similar establishments also, having power input, and the number of output in DC will be one, and the number of output in AC will be three. So as it is a three-phase supply, and then connector specification also, connector specification shows that GB, which is GUBIO standards. It is a Chinese national standard. So according to that, this connector specification is shown over here, and then communication protocol are also shown. So these are the AC and DC standards that are followed by companies in electric vehicle. So having standards for electric vehicle, for in terms of hybrid electric vehicle, some standards and codes are made, such as AIS 102, which is CMVR type approved for hybrid electric vehicle with gross weight value of gross vehicle weight of 3,500 kg. So this is the category that is established by ARAI for manufacturing and electric vehicle, and for manufacturing this type of electric vehicle having a gross vehicle weight of 3,500 kg, AIS 102 code is to be followed. And then for having a gross weight value of more than 3,500 kg, AIS 102 part 2 code is to be followed with the vehicle type of M and N category. And in M category, passenger vehicle is going to come over there, and in N category, goods and services vehicle is going to be come over here. And these are the above codes which have been referred from the European standards of ECER 100. And ECER 100 is an approval code for battery of electric vehicle. And then ECER 101 is an approval code for passenger cars of M&N category. And then similarly, ECER 83 and ECER 85 are the approval code for the emissions of pollutant. So some European standards are also have been taken in order to maintain the equivalent specifications for electric vehicle. Now moving ahead, for retrofitting a vehicle, what are the codes and standards that are going to be specified? So AIS 103. AIS 103 is a different code which is established for retrofitment of vehicle of M and N category. M is the passenger and N is the goods category, having a gross vehicle weight of 3,500, less than 3,500. And then AIS 103 part 2 is of retrofitting of vehicle of M and N having a gross vehicle weight of more than 3,500. So AIS 103 is basically a CMVR type approval of hybrid electric vehicle system, which is intended for retrofitting of vehicle. So if we want to change our normal vehicle into a retrofitted electric vehicle, then what are the codes and standards that are going to be followed by a particular organization? And according to that codes and standards, we can have a retrofitted vehicle that is going to be run on the road. So for making that retrofitted vehicle, this AIS 103 123 code is going to be followed. A proper rule book is also available on the Google. If you have gone through that, then you will have a better idea how these codes and standards are going to be followed and what are the specifications written in that rule book for a particular type of component. We'll have a look of it afterwards. Then you can compare what codes and standards can bring a change into our specifications of a vehicle. So if you can see the before image of a vehicle, it is having an unambiguous system setting, and no such components is established according to the requirements. And if you see the after image, after following the codes and standards in electric vehicle, you can see all the components are duly well settled and well systematically arranged so that each and every component can be accessed easily. So these are the changes that a codes and standard specification, if to be followed by all the organization, can bring us. So government is trying to apply all these codes and standards in all the related all the electric vehicle organization related firms, so that we can have a good product that is going to be run on the road. Now, having some standards for 250 watt of EV certification. So having battery operated vehicles with following specifications are not deemed as motor vehicle and has exempted from CMVR. So having vehicles having 30 minutes of power of motor is having a voltage of a watt of 250, and these vehicles having a maximum speed of 25 kmph. So vehicles having such type of specifications are come in the category of 250 watt EV certifications, and then they are being judged and they are being designed and developed on the basis of this 250 watt EV certification standards. So moving ahead, so with what are the policies that are going to be established for following these codes and standards? So let's have a look over this. So what are the requirements of these policies? So policy making for electric vehicle are going to be used for domestic cell manufacturing, which is having some low labor cost, and accordingly, if we include all the policies related to electric vehicle in the incentives and manufacturing, then the efficiency will automatically be improved, and the assurance of demand will be also there. Because as soon as the manufacturing of cell is considered, the number of cell are considered that are manufactured in India in today's market are low as compared to other vehicle and other countries. That's why their cost is high, and then due to this, their demand is quite low. So if we improve the efficiency of this, and low labor cost is to be considered in that, then we can also say that the demand is going to be increased in coming years. So what are the cost reduction strategies that we can follow? So we will having in incentivizing cell manufacturing with support for domestic manufacturing and related linkages. So if a cell is to be manufactured by a firm, and then it is going to be sold in the market. So if we apply some incentive to that cell, then we cell manufacturer, then we can be able to reduce the cost of that. And then we will be having a development of ancillary industries for pack components, and then incentivizing reverse logistic reuse for stationary uses. Reverse logistic is basically the process of moving goods from their typical final destination for the purpose of capturing value or proper disposal. So this reverse logistic can be a very helpful option in reducing the cost, which is going to be used as a process of reuse and recycling. And then improving the availability of critical cell components also is going to be a strategy which support the domestic manufacturing and related linkages. And then standardization and then battery as a service can also be a strategy to reduce the cost. If we set up a battery service station along the roadside, then we will be having a reduced cost of batteries, and batteries can be get serviced out there, so that a new battery cannot be required in a short time duration. That's why we can able to increase the lifespan of a battery. So we can also establish service station for batteries out there to reduce the cost. And then demand education and dedicated battery research institute. Basically, what is going to be happen, what is going to be planned is that if we design and develop a battery by ourselves, then one battery will going to be having a higher cost. And then if we establish a dedicated battery research institute out there, then it will be going to have a better result of that, so that we can also increase the efficiency of the battery by doing research over there, and by adding additional value to it. So more customer focus will be on the battery side out there. So that is how we can reduce the cost of each and every components, and then we can see a drastic reduce in the overall cost of electric vehicle also. So as far as focusing on development of ancillary industries are considered, So manufacturing ancillary components domestically is going to be one of the major idea that is going to reduce the cost overall, and then develop and integrate with global value chain. As far as the standards and codes are considered, so ASTM and ANSI are going to be the international bodies that have designed and developed these codes and standards. And if we going to follow these codes and standard according to the global value, then we can develop and integrate our product according to their standards also, which will automatically improve the efficiency and then industries for pack components. So the major term that is going to be used is here the reverse logistics. I have already explained you what reverse logistic is. Let me tell you once again. So reverse logistic is the process of moving goods from their typical final destination for the purpose of capturing value or proper disposal. So this is what reverse logistic is. And due to this, cost can be recovered from recycling and reusing all the components, and then increasing share of renewable energy also. Using this reuse and recycling phenomena, we can reduce cost up to a greater extent. Then availability of critical cell components. As you can see, majority of the components that are going to be used in making a cell or a battery pack are not going to be manufactured domestically. That's why they are costly, and due to this the overall cost of the battery or overall cost of the vehicle will increase. So if we are starting to manufacture cell domestically, and also procurement of rare raw material going to be started within our country, then it can reduce the cost to up to a greater extent. And then geopolitical efforts can also be used to ensure availability. So geopolitical efforts are basically the study of efforts of earth's geography on politics and international relations. So these are the major factors that are going to be considered if we want to reduce the overall cost of a vehicle. And if they are going to be followed and used in vehicle at a greater extent, at a greater overview, then we can have cheaper vehicle that are going to be run on the vehicle on the roads. So what are the standardization that are going to be followed before applying a policy? So to prevent the entry of non-standardized batteries. So basically, you can see many of the firms are going to be use non-standardized batteries. So this is going to be stopped. The major standard battery is lithium-ion battery or lead acid battery, which is basically used in electric vehicle. And then using these types of batteries can set up a basic standard for the companies, so that they can also go for these type of batteries instead of any non-standard battery, which will avoid the unsafe and cheap battery uses. As standardization is the confidence in the market. So if you are going to buy a battery, then you will select a specific battery that you are going to have, that you are going to see in the market, which is having a demand over there. And why is the demand in the battery in the market is because that battery is going to be the standard battery for electric vehicle. So we have to specify some of the standards for battery manufacturing also. For battery as a service, what are the specifications for policy making? So innovative business models which will reduce the cost of a battery up to a greater extent. For example, if we are going to establish a firm which is going to manufacture batteries only, and it will going to manufacture, let's suppose, 1,000 batteries in a year. So the overall cost will going to be reduced per battery, as how it is going to be produced 1,000 batteries, and it is having market research over there that minimum of 1,000 batteries can be sold in that financial year. And by considering all these factors, the cost of a battery will be reduced. So before buying or before presenting any of the model before a customer, strong presentation is to be required, as the customer is going to be attracted with the model or with the component that we are going to sell. With the is going to be attracted by the main point, that is going to be the USP of that product. And by highlighting that USP of the product, we can get maximum number of consumers. And then we can also specify that just a part of a battery cord is to be paid and then it could be replaced. This thing is going to be followed in coming years in many of the countries, that the electric vehicles which are having their batteries not functioning quite well, they can exchange their batteries, and in exchange they'll have to pay only a part of the battery cost, which will not increase the overall cost of their vehicle. So this is the strategy that is going to be applied on electric vehicle in coming years in India also. And then demand aggregation also. So bulk procurement is can be done to reduce the cost, which will assure the demands of that product also. And then we will have to strategize the problems. How we can strategize the problem? We can, if we develop a product over there, then we have to test that problem, and after testing we can find some of the major effects and major problems that are going to occur in future in that problem. And based on these effects and based on these problems that are going to occur on that, we can prepare strategies how to overcome with these problems. So these are the demand aggregation that we have to follow in terms of battery. So for having a dedicated battery research institute, we have to follow a network approach, which is availability of information for trending technologies to industry. We have to find out uh, the opportunities that we can develop in terms of battery management system, in terms of battery manufacturing. If we are able to find out those availabilities and those trending technologies that are going to have in the future that present, and based on this approach we can also establish a dedicated battery research institute. We can also establish this institute in any of the manufacturing firm also, so that the additional information that are going to be used by this research institute can also be available easily for them. And then what are the alternatives, or what are the priorities that are going to be set by the firms in terms of making the electric vehicle? So first of all, the major priority component will be incentivizing cell manufacturing, which is giving to a priority of around about 25%. As cell manufacturing is going to be one of the most costly process in today's world, and if it is going to be incentivized, then the overall cost will reduce. And then improving the availability of critical components like lithium, cobalt, graphite is going to be the second most priority, as most major of the batteries that are going to be used in electric vehicle are lithium ion batteries having cobalt and graphite components in it. So that is how it is going to be focused on the priority list. And then standardization of battery standards and development of ancillary industries for pack components, and after that incentivizing reverse logistic reuse for standard stationary uses, and the demand aggregation for demand in case of public transport can also be considered with the priority list below there. Due to by what we can have after prioritize each and every component is that after this we can just focus on the majority of the component that is going to be the most important factor in defining the cost of a product. For example, if we have designed a vehicle, then the major parts that are going to be designed are suspension system, and then transmission system, and then braking system, and then with the steering system, and then roll cage or chassis. So dividing each and every component with their priority, what we can conclude that chassis is going to be the major part that is giving the most priority to it, as a chassis will only not ensure the availability of safety to the driver, but it will also help to join all the related sub components to it. So in terms of a vehicle, if we're designing a vehicle, then chassis is going to be the utmost priority out there. And similarly is going to be happen in the battery management system or electric vehicle. So the incentivizing of cell manufacturing is going to be the most priority, which is having 23.18%. So this is how you can set the basic priorities to each and every component in electric vehicle. Now we are having some AHP problem hierarchy. So if we are having a number of policies, let's assume we are having number of policies just such as A, B, C, D, E, F, G, and H. Then if we want to select the best policy available over there, then what are the criteria that we are going to set over it? Is that first most criteria will be what is the impact on the cost of that policy, and then what is the time that is going to be take to implement that policy, and what is the investment required in that policy. So for enhancing policy operations in electric vehicle component and in electric vehicle field, we have to consider the major three criteria, that is impact, time, and investment. And after considering all these factors, we will be getting the best policy option, which is the goal of our electric vehicle manufacturing. So this is how you are going to establish and identify the best policy option that is available in the market. Now, in terms of weight criteria, so the impact that is going to having a weight is of 0.64 per number, and then time and investment is having 0.22 and 0.14. So as compared to the that hierarchical table that we have shown in the previous slide, the impact having the majority of weight as compared to time and investment. Now, key policy areas are support for domestic manufacturing and related linkages. It is the economic type policy, and the implication of battery on battery cost is going to be a direct implication, as the domestic manufacturing and related linkages is going to be used directly in the battery, and that's how uh, the battery cost will be increased directly. And then government procurements, support for charging infrastructure, and then support for innovative business models, and then reuse and recycling, standardization, and network management are going to be the key policy areas which are going to define the overall cost of an electric vehicle. You can see government procurement and support for charging infrastructure, and these type of policies are also having an indirect effect through electric vehicle demand. So if we are using a policy of government procurement, so procurement and communication and diffusion due to visibility of EVs. So based on this criteria, it is going to be dependent on electric vehicle demand. As the number of electric vehicle cell will increase, then the impact on battery will also be there, that we can see. And in compared to support for charging infrastructure, the support for innovative business model is having a direct impact on the overall cost of a battery. So these are the key policy areas that we have to look after before designing and developing an electric vehicle. And after designing and developing an electric vehicle, we have to set some codes and standards according to the market needs, according to the customer requirements. Now, having a battery value chain and their development stage in India, so we will having a stage of material sourcing, in which we will have to import a material, what type of material is required to develop and design a battery, and then component manufacturing such as electrode, separators, casing, and then terminals, and then cell manufacturing stage is going to over there, which is having a cell of Panasonic, Exide, and then packaging stage is also there, then vehicle integration stage, then usage profile stage, and then second life or reuse stage, and then afterlife of recycling stage, and then research and development stage. So these are the stages that are going to be focused in the terms of battery value chain and their development in India. And the current potential companies and suppliers for all these components, we can also have a look at over it, such as for packaging, Mahindra, Ather, Exide, and Amara Raja, and then Sun Mobility are the major companies that are going to have a hands in the packaging. And then in terms of vehicle integration, Mahindra, Tata Motors, Ather, Sun Mobility, Tork Motors are the companies that are going to be present in India. And then for research and development, it is going to be the most important stage for battery value chain and their development. So R&D is required along all aspect of the value chain, especially in the new chemistries and format. So if we are going to design and develop a new type of battery, so what are the research specification is going to required over there? What is the development of technology that is going to be used over there is going to be a major aspect over there. So we have to consider all these aspects. And in terms of this research and development, IIT Madras, Kharagpur, Mumbai, NPL, ISRO, OEMs, startups, and many more organizations are present over there, which are having some effect on the quality of the battery. Now, if we have a look on the overall electric vehicle share in the market, so you can see the government organizations are using this much percent of electric vehicle are going to be used this much percent of electric vehicle in the year 2025, and then personal usage is going to be increased drastically as compared to the previous 5 years in terms of the coming 5 years. So in 2024 and 25, the personal usage of electric vehicle is going to be increased drastically, and due to this the battery usage is going to be increased, and for this battery usage we have to make some policies. So that's why policy making also important in codes and standards. And then government organizations is having this much share, and then shared mobility providers are going to have a usage of this green part is the shared mobility providers, which are going to having use which are going to use public transport for example. Now in 2020, so what is the EV sale that is going to have over there? So as compared to Jan 2020, in April 2020, only 900 electric vehicles are sold over there due to the pandemic that is going to create a major effect on the economy of the country. So, as focusing on Jan and Feb electric vehicle sales, we can see more than 15,000 electric vehicles are going to be are sold in the year in the month of January and February of 2020. So based on this criteria, we can easily have a result that electric vehicle are going to be a booming field in coming years, and we have to set some standards, some rules, and some regulations for design and development of electric vehicle in India. Now, what are the challenges for electric vehicle? So, if let's suppose we have designed an electric vehicle according to some codes and standards established by some organization. So then what are the challenges that is going to be faced before coming into the market, or after coming into the market? Let's have an overview of that. So the major objective of this challenges that are going to face by electric vehicle is high initial cost, and then maintenance cost, and then total cost of ownership, and then EV adoption. So these are the major factors that are going to create impact on the cost of the vehicle and on the future aspects of the vehicle. So for high initial cost, you can see costs of a mid-size electric vehicle is around about 40% more than a conventional IC vehicle. This is due to expensive hardware, expensive technology, and low production rate. So in coming years, as the design and development and the production of the electric vehicle is going to be increased, the cost is going to be reduced as well. So but in today's world, in today's scenario in India, as considered to the other countries, the electric vehicle is going to be a 40% more expensive in terms of as compared to conventional IC vehicle. You can see the vehicle that are going to be used batteries by 2030 are going to have a cost value of nearby 25 to $30, which is going to be reduced by 48 to 18%. So this is the most drastic change that we are going to see in coming years in terms of battery electric vehicle, because more the production will increase, more the demand will increase. And as we are going to shift from commercial IC or EC engine to electric vehicle, so the demand will increase slowly, and in coming years we can see a drastic change in terms of this graph. you can see the cost will going to be reduced of electric vehicle as compared to IC medium vehicle. Now, in terms of maintenance, you can see as there are less number of vehicles in India as compared to other countries. So this is the majority reason. The reduced number of electric vehicle is going to be the most important reason of high cost. But as compared to IC vehicles, the maintenance cost is quite less, as there is no engine over there and there is no pollution over there. So the maintenance cost will be going to reduce by a rapid rate. And then other necessary replacement are like brakes, insurance, structural repairs are having a less maintenance cost. But the majority thing is going to be covered by the battery. So as compared to any other component in a vehicle, the battery is going to be a major part that is having a very expensive battery replacement, which range about US dollar of 3,000 to 10,000, nearly 2.25 lakhs to 7 lakhs. If this maintenance cost of battery will reduce, then the overall cost will going to be reduced. So we have to focus on this battery reduction cost. You can see the lithium ion battery, which is having a sale of 2000 in 2010, it is having a cost of 1200 a dollar per kilowatt hour, and in coming years you can see it is going to be reduced to nearby 100 dollars per kilowatt hour. So this is going to be the target that is going to be set in India for maintaining and optimizing the vehicle compatibility in terms of electric vehicle. So total cost of ownership, in terms of total cost of ownership, purchase price of an asset plus the cost of an operation is going to be the major factor that is going to be considered. And then operational cost of electric vehicle is much lower than conventional vehicle. As you can see in conventional vehicle, engine is used, and along with this, radiator is used, and with this fuel is going to be consumed over there. So all these requirements are going to be faced by a commercial vehicle, and as compared to a conventional vehicle or commercial vehicle for which is going to be used as engine vehicle, the electric vehicle is much more cheaper, as it is only having a battery and a motor over there, or in terms of hybrid if it is having an engine. So this is the major effect that is going to create on operational cost. You can see Nissan Leaf, which is having a value of $3,919, is compared to with a Hyundai gasoline cost, which is having a 10,990 for the next 10-year period. So Nissan Leaf is going to be one of the majorly used vehicle in terms of Indian market as compared to any other vehicle, as it is going to be a cheaper vehicle. So you can see this is the price survey for lithium ion battery. So battery pack in 2010, as we have already discussed, battery pack real price in 2010 will be 1,160, which is going to be reduced by 899 in 2011. And in coming years, so by 2018, it is having a drastic reduction of 18% as compared to 2017, which is having a value of 176 per kilowatt hour. It is the cost of a battery in dollar. So this is the lithium ion battery price survey. What this survey shows to you is that as far as the demand of electric vehicle will increase, the lithium ion battery cost will also decrease. And due to this, we can have more number of electric vehicle on road in India. So in terms of EV adoption, so we are going to switch from a commercial vehicle which is going to use engine, IC engine, to an electric vehicle having a motor and a battery. So we will have some rules and regulations in terms of formation of government bodies for formation of policies and standards. And such standards in India are going to be formed by ARAI itself. And then government incentive for hybrid and electric vehicle will also be going to be a major point over there. And then we will have to extend the charging station project. You can see as compared to the world, in the world as compared to India, the world has shifted towards automatic charging stations and solar charging stations. And if we are going to follow that trend in India also, then we can have a reduced cost of electric vehicle, and we will be going to adopt electric vehicle switch more fastly as compared to any other country in the world. Then we can also have some proposals of retrofitted vehicle as compared to new vehicle. So if anyone is having less cost, if anyone is having low budget, then they can also go for retrofitted vehicle from an old conventional vehicle. So this is going to be the most majority factor which is going to be help by the to the people to shift from conventional vehicle to electric vehicle. You can see the stock and charging infrastructure needed by 2050 based on EEI and IEE forecast is going to be shown over here. So EV charging ports by 2025 are nearby 5 lakhs that are going to be required by the people. And this value is quite less in 2017, which is less than 1 lakh. So you can see the demand is going to be increased as far as the electric vehicle is considered. So if the demand will increase, then the overall cost of the vehicle is going to be decrease. And you can see majority of the vehicles are electric vehicle in terms of Indian market. So e-auto are going to be is introduced in Gurgaon, and then e-taxis are majorly used in Nagpur, and then e-buses are also present in Mumbai. So you can see e-buses in Mumbai are having a number of 3,144 vehicles of e-buses, and then e-taxi are of 2,430, and e-auto, electric auto, are of number of 21,545. So these are the particular cities in which these e-vehicles are introduced. So we are shifting quite fast in terms of electric vehicle mobility, and this is going to be a most booming field. So as compared to IC vehicles, the EV market share is shown over here. So total power hybrid electric vehicle or total battery electric vehicle share is shown over here. So you can see in 2010 there is no hybrid electric vehicle or electric vehicle that is present over here in India. So as compared to 2010, we came to 2020. So we can see there is a bit use of battery oriented electric vehicle in India, and IC engines are going to be reduced after that. So this is the overall projection that is going to happen in coming years. So by 2030, more EV market share is going to be increased. This is the EV market share WOM that is going to be increased by 20% in 2030 as compared to 2020, which is around about 5 to 10%. So you can see there will be a demand of electric vehicle, and if there is a demand of electric vehicle, then there will be overall cost reduction also. So these are the major companies that are going to work that are working in electric vehicles, such as SMEV, which is Society of Manufacturers of Electric Vehicle, and the NITI Aayog, and then National Electric Mobility Mission Plan, and then Energy Efficiency Service Limited. These are the majority companies that are regularly working in electric vehicle design and development, and these are the organizations that also working to provide efficient knowledge, to provide quality knowledge in terms of electric vehicle with the help of some organizations. And one such organization is our organization, which is ISIE India. We are currently working in the field of electric mobility, and in this field, what we are doing is we are going to organize some of the events based on electric vehicles, such as ESVC event. It is one of the most popular event in the field of electric vehicle. And then Hero e-bike event, we are going to organize over that also. And we are going to organize these events in the coming years, and registrations are till now open. So we are inviting all the colleges and universities to participate in those events. And along with this, we are going to have a skill development cell also in our Imperial Society of Innovative Engineers. And currently we have launched a 1 year certified diploma program in electric vehicle. And based on in this program, we are going to cover each and every aspect of electric vehicle, how electric vehicle are going to be designed, how it is going to be developed, how what are the battery specification that you have to select in the in any of the component or any in any of the vehicle, how batteries are designed. We are going to have overview of designing a battery on MATLAB Simulink software, and then designing on SolidWorks. So these are the major aspects that are covered by our course, which is 1 year certified diploma in electric vehicle engineering. And we are providing 6 months of study out there, and then we are providing assured internship to the students also, and for 6 months. In all the SMAB associate companies, we are going to provide internship. So these are the major steps that are taken by ISIE India in terms of electric vehicle. So we are rapidly switching towards electric vehicle, and all the requirements that are going to be faced by the industries are going to be fulfilled by some of the organizations. And one such organization is our organization, which is providing quality education in terms of electric vehicle. And yeah, that's all for the session. Thank you.
Yes, sir. So thank you so much, sir. I request participants to post their queries in the chat box.
Yeah, if you are having any query, you can ask me.
So you can directly ask or you can post in the chat box so that I can address to the speaker. So I think no queries from the participants.
Yeah,
So shall we conclude this session, sir?
yeah, sure, sir. Sure, sir.
Yeah, yes, sir. So thank you so much for the informative session regarding the codes and standards of electric vehicles. Thank you so much, sir.
Yeah. You're welcome, sir. Welcome, sir.
Yes, sir.
So if anyone is having any query, and if anyone wants to explore their knowledge in the field of electric vehicle, then
Yes, sir.
we
We will
warmly,
definitely share the email ID and WhatsApp number to
yeah,
them.
sure. We warmly welcome to come to our website, to just visit our website, and you
Yes,
can
sir. Yes.
find all the related courses on electric vehicle over there.
Yes, sir. Yes. We will inform to the participants. Thank you so
Yeah,
much.
okay, sure. Okay. Welcome, sir. Welcome.
You can leave. Sir.
Yeah,
So I
okay. Thank you,
request,
sir.
yes, sir. So I request participants to fill the feedback and attendance links of the session 3, which is posted in the chat box. So for tomorrow's session, we will be providing you the new link. It's been already sent to your register mail IDs. So for day 2, the link remains same for all the 3 sessions plus one more session which is being conducted from 7 o'clock to 8 p.m. in the evening. So I request to the participants to join tomorrow's session at 10 o'clock will be the first session. So 3 sessions will be covered in the morning hours, and at the evening there will be one more session which will be covered. Okay. So thank you participants. Shall meet again tomorrow. Thank you so much.